Number 11. The torque caused by a force F applied at a distance r from the axis of rotation is given by torque equals r F sine theta, angle from r to F. What other angle? If the magnitudes of r and F remain the same, what other angle theta prime will produce the same torque as produced at an angle theta if theta was less than 90? So here are our choices: 90 minus theta, 90 plus theta, and 180 minus theta. So 90 minus theta would be coming up this way, 90, and then coming back this way, theta. 90 plus theta would be coming up this way, 90, and coming over this way, theta. And then 180 minus theta would be coming over this way, 180, and then coming back, theta. Now, which of these compares well to theta? This one has symmetry so that the sine is the same. Sine theta is that part. So the answer is 180 minus theta. There's also an angle addition formula for sine, and if you take sine of 180 plus b, it's cosine 180, which is negative 1, times sine theta, plus the sine of 180, which is 0, cosine theta. So it's cosine 180 times sine negative theta is negative 1 times sine negative theta, which is positive sine theta. Number 12, two equal forces are in opposite directions and their lines of action are separated by a distance d. Two equal forces are in opposite directions and are separated by a distance d. These two forces are applied to a solid disk which is mounted to a frictionless axle. If d is half the radius of r, which of the following positions for the forces would give the most torque? A. One force on a line touching the circumference of the disk and the other on a line halfway to the center. B. One force on a line at a distance d from the center and the other on a line through the center of the disk. Or C, one force on a line at a distance d over 2 from the center of the disk and the other on a line at a distance d over 2 on the opposite side of the center of the disk. So if you want to use the torque formula, it's distance times force for each of the two forces. In this one, you could measure the distance from the center, for instance, and the counterclockwise force is 2d, and the clockwise force is at d. For this one, the counterclockwise force is at d, and the counterclockwise force is at 0, but it's not really counterclockwise or clockwise. In this case, both forces are going counterclockwise, so it's d over 2f plus d over 2f. So anyway, all three of them come out to be the same amount of torque. However, they would not necessarily produce the same angular rotation because around this center you have a minimum moment of inertia. Over here you have a much higher momentum of inertia around this axis. So this would produce a slower angular acceleration trying to spin it around that axis than it would trying to spin it around that axis. Problem 13. Masses are distributed in the xy plane as follows. We've got 6 kilograms at 0, 0, 4 kilograms at 2, 0, and 5 kilograms at 2, 3. The equation for center of mass is basically the sum of masses times the position divided by the sum of the masses. So I'm going to write that as 6 times 0, 0 plus 4 times 2, 0 plus 5 times 2, 3, all divided by 6 plus 4 plus 5 is 15. And we will end up with 4 times 2 is 8 plus 10, 5 times 2 is 10, comma, 0 times 4 is 0, plus 5 times 3 is 15 over 15. So it is 18 over 15, or 1.2, comma, 15 over 15 is 1. So the x-coordinate is 1.2, and the y-coordinate of the center of mass is 1. This problem just asks for the x-coordinate, so it is 1.2. Number 14, Tasha has a mass of 20 kilograms and wants to use a 4-meter board of mass 10 kilograms as a seesaw. Her friends are busy, so Tasha seesaws all by herself by putting the support at the system's center of gravity. When she sits on one end of the seesaw, or one end of the board, how far is she from the support point? So we've been given the girl's mass and the board's mass, and we are given the length of the board, L. So there's one variable here to solve for. On one side, she's sitting R from the end of the board, and if you subtract R from the length of the board, that is the length of the board on the other side. And we also know that this distance here is L over 2 from the one end of the board to the center of mass of the board. So what spot we use as our origin? We could use this as our origin. 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 I think I'm going to think in terms of torques around this point, because I just feel like I've got everything labeled in that direction. So this down arrow produces a clockwise torque of m sub b L over 2. This one produces a counterclockwise torque of L minus R times m sub b plus m sub g. See, she is, because both the board and the girl are pushing down there. And the last one is the girl's torque, which is clockwise, pushing down with m sub g times L. So clockwise, counterclockwise, clockwise. Usually we make counterclockwise or clockwise negative and counterclockwise positive, and this should all come out to be 0. Okay, so there's our equation of equilibrium of torque. Now we just need to solve that for R. And R is only used once here. I'll put m sub b plus m sub g times L over on this side. Oh, m sub b over 2 L equals L minus R, and we'll divide by m sub b plus m sub g. So from there, I'm adding R to both sides, subtracting this big mess from both sides, and then bringing my 1L down. Then I multiply the 1 by mb plus mg over mb plus mg, basically getting a common denominator. And that makes the mg cancel out, mg minus mg, but you're left with the m sub b over 2. M sub b minus m sub b over 2 is m sub b over 2. And then, so this comes out fairly nice and neat at the end. And you can plug in your numbers. The board is 10 kilograms, the girl is 20 kilograms, and the length of the board is 4, and it comes out to be 0.667 meters. Next question. A 4.0 kilogram mass is placed at 3, 4, and a 6 kilogram mass is placed at 3, negative 4. What is the moment of inertia of this system about the x-axis? And notice that we've got the similar question here about the y-axis, and I'm just going to do the z-axis as well while I'm here. So first of all, let's kind of picture this. Here's the x-axis. I'm going to draw the y-axis kind of. So it goes back into the page this way, and then I'll put the z-axis right here. And we're going to put the objects at 3, 4, 1, 2, 3, 1, 2, 3, 4 up here. And then the other object will be at 3, negative 4, which is 1, 2, 3, 1, 2, 3, negative 4, 1, 2, 3, 4. So down here. All right, and then looking at the x-axis, here's the x-axis. The radius is 3, no, 4 from there, about the x-axis. So how do you say that? The moment of inertia, I sub x equals sum of m r squared, where r is the distance from the x equals 0, or wait, x equals 0? No. The line, this line is the line that says x or y equals z equals 0. That's what that line is. And this line, the z, is x equals y equals 0. And the y is the line x equals z equals 0. So both x and z are 0 on this line, both y and z are 0 on this line, and both x and y are 0 on that line. But so what we're interested in for this one is just this distance here. The so 4 kilograms times 4 squared plus 6 kilograms times negative 4 squared. For I sub y, that's going to be pretty strange behavior, because we're going to be rotating around the y-axis. It's going to be rotating like this, but the distance there is going to be 1, 2, 3. So here again we'll have sum of mr squared will be 4 kilograms times 3 squared plus 6 kilograms times 3 squared. Now for I sub z, we need to look at this distance and this distance, and so I'll say I sub z is equal to, and the distance here is square root of 3 squared plus 4 squared. It's a right triangle over here. There's a right angle, and or over here. There's a right angle. And anyway, this comes out to be 5, so it'll be 4 kilograms times 5 squared plus 6 kilograms times 5 squared. And the circle would be like that in the z-plane. I didn't draw the first circle that goes around like that in the it's not in the YZ plane, but it's like 3 units in the X direction above the YZ plane. And the answers come out to be 160, 90, and 250 kilogram meters squared. Answers C, A, and B for, just A and B for 15 and 16. A is 160 kilogram meters squared, and B is 90 kilogram meters squared. And if I'd asked about the z-axis, it would have been C, 250 kilogram meters squared.